Hey guys, welcome to my YouTube channel. Today let's take a look at the simplest method to create a custom object detection model. For this, what would you need? You would need a Windows, Mac or a Linux PC, a Google Colab account, that is where we'll be training because it provides us with free GPUs, and a Python 3.5 plus compiler installed. So what were the steps that we would be following for this application? We would first get the data set, and then we would adding the bounding boxes, the boxes around objects that we would want to detect. Third is we would train the model using Detecto, which is a package, and we would train it at Google Colab, and at the end we would visualize the result. So let's get started. I found a wonderful dataset that we can use for this application. It has a license by which we can use the dataset. It contains images of Lego figures. We'll be modifying the dataset and using a subset of it today so that we can train our deep learning model. We also need to put a box, which is called the bounding box, across all objects which are the Lego figures so that we can label them correctly. I'll put the link to this dataset in the description below. This is how the files look once you download the Kaggle dataset. Today we'll be making use of the Marvel Lego figures. That is the 0001, which contains the images of Spider-Man, as you can see over here. 0002, which contains the images of Spider-Man with Venom, like the one in the Tobey Maguire Spider-Man 3 movie. And also the 0015, which contains the Lego figure images of Iron Man. Add labels to the image, we use a package called label.img. This package has a very easy installation. I don't want to build it from source, I want to install it using pip. The command is something that you can find over here. I will copy and paste it right here. And this would install the label.img package. And to run it, all you have to do is type in label img and hit the enter key. And this opens up such an interface. Here is the label image application which is open, and then now I would click on the opendir function over here to open the directory where I want to make changes. So this is the one where I have all my images, so I would say open, and as you can see over here it brings out all those images, and we can go ahead and start the labeling process. To start the labeling process, you can click on the create rect box, which would allow us to create a rectangle box, which is our bounding box. So once you add a box on top of the figure that you want to label or the object, you can give it a name. In this case, it's Iron Man. So I'd give it the name Iron Man and click on OK. And do not forget to save the changes. For example, if I don't save the changes, if I go to the next one and then come back, I don't see my box, the bounding box that I had created. So please do save your changes before moving ahead. I would label it as Iron Man and I would save it. Yes, in the same directory. And I would go ahead to create the next ones. If you're using a trackpad, it's better to switch out for a mouse. That way things are much easier. So now this is a different image. So I would change the label to Spider-Man 3. Because this was in Spider-Man 3, the movie with Tobey Maguire. Make sure that you don't add in objects that you don't want to be detected. For example, over here, the Spider-Man is on a hoverboard sort of thing. So I would crop in just on the Spider-Man in this image. I would have to change the label over here because this was in the Spider-Man 1 movie. There you go, I missed saving this one and I lost the bounding box. So again, please do make sure that you save them. And that's it. We have created bounding boxes for all the images present over here, as you can see. Now we can go ahead and start with the deep learning process. Before we start the training process, we need to install a package called Detecto. It is like a wrapper which is built on top of Pytorch. This uses faster RCNN ResNet 50. And if you click on the link, you can go to the Pytorch website and take a look at it over here in much more detail. So it is a type of a architecture of a deep learning network, neural network, and then you can use it. It is pre-trained on a few classes, but then you can train it to detect your own images. For the purpose of this application, I have uploaded all the images and the XML files that were generated to Google Drive, and I'm connecting Google Colab with it. Google Colab is a really nice platform which gives you access to CPUs and GPUs, which you can use for your training process. So here is my Google Drive where you can see all the images as well as the XML files. And I have connected my Google Drive to Google Colab using this code over here, which you can do as well. Coming back to Detecto, I can install Detecto by running the command pip install Detecto at Google Colab. I would use the exclamation mark at the start because this would run the whole whatever command that I want to run on the command line itself and not as a Python code in a notebook. So once I have Detecto installed, this is how you get a message saying successfully installed Detecto. So now let's get started with the deep learning part of it, that is using the Detecto package. Now let us visualize one of an image that we have uploaded and see if we can really access it or not. For that, I would have to import matplotlib, pyplot, as PLT is just an alias to call it in a simpler way. And from detecto.utils, I would import read image. So Detecto also has utility packages in it using which we can read image, write things, save our model, etc. Once we do this, let us actually read an image. For that, I would create my base path, which is nothing but the path to my Google Drive. And let me just paste a name of a sample image, such as this one right here. Okay, now let me read that image. And plt.imshow will draw that image out for us, and plt.show will display the image on this collab notebook. And as you can see, we still have our Spider-Man here. So now next what we'll do is we will load the entire folder as a data set. So now let's create a dataset object, which is done by reading the dataset folder, which is in my Google Drive. For that, what would I do is import a package from detecto.core. Sorry, this is actually a class. So what would I do is I would assign a class object to a dataset variable, and this would take the base path as the path from where it has to read things. So once I start running this, this would go through the entire contents of the folder and read both the XML and the JPEG images. So let me show you how an XML file looks like. This is the contents of my folder, which contains both the JPEG and the XML. When we did the label image bounding box, it creates an XML file which looks something like this, where it has an annotation, it has the folder name, it has the file name, it has the path, which is the path in my local system, which we don't actually need as of now, but it does create those. It does create a size object, which is nothing but the width, height, and the depth of the image. Depth is 3 because it is a RGB representation which has 3 colors, and the width is pi12 and the height is pi12. And this is actually the part where the bounding box is. So you can see that the label for the bounding box is Iron Man, pose is unspecified, truncated 0, difficult 0. You can also assign all of these variables if you need. And here is the bounding box, which has the xmin, ymin, xmax, and ymax. So the xmin is where the actual bounding box starts. It can be somewhere over here. Xmax is the maximum x value until where the bounding box goes to. Similar case with ymin and ymax. Ymin is where the bounding box starts, and then ymax is the maximum y coordinate until where the bounding box goes to. So once we have the dataset loaded, let us visualize one of an image with a bounding box with it. For that, what I would do is that from detector.visualize import show labeled image. This is a function that we can call. So this gives out two return values. One would be the image and the other one would be the targets. Targets would actually contain the bounding box and the label that we gave it. So I would choose the first image in our dataset object that we just created. So now I can call the function with image and targets, where I give it the bounding box or bounding boxes if you have more than one in a same image. And then I give it the labels, that is the labels that we added to the image. If you take a look at them, here we have the image of Iron Man, and then we have the bounding box representing it. So what you see over here is a little different from what we saw in the JPG image. That is because the Detecto package does some pre-processing on the image where it has converted the whites to yellow so that there is a better understanding for the model on how it has to perceive the object in the model. Let us check out another one. Yeah, as you can see here also there is some pre-processing done on top of it. You can customize this pre-processing by using the transforms in the Detecto package. That is something that you can do. So now let's go ahead and build our deep learning model. For that, we need to import a few things from the Detecto package. Here we import the data loader, which loads the data, that is the XML and the JPEG, in a format which is readable by the model and also the model itself. So now we need to specify the labels, which were Iron Man, Spider-Man 1, and Spider-Man 3. This way the model knows that these are the three objects which are the Lego figures that we are trying to detect. And then we create an object of the model class where we pass in the labels. So this would actually download the ResNet 50 package because it is already pre-trained, and then it fits it with our labels. The fitting process is what we'll do now. To fit the model, all we have to do is call the fit function. As you can see, it takes the data set and a few hyperparameters that you can tune. The epochs is the number of times it sort of trains the model. It's like a loop which goes on and on and on. There is a validation data set that you can actually assign, where you can get a validation score as to your model is overfitting or not. There is a learning rate which you can modify, and there are various others such as the gamma or the learning rate step size, which you can later go on and change. For our purposes, let's use the basic or the minimum that we have, that is the data set itself for now. And this would go ahead and start the training process. As you can see over here, the model has been trained for 10 epochs. Now we can go ahead and make a prediction. To make a prediction, we need to read an image, a random image first, and then we can try to predict the contents of that image. So let's use the same read image function that we had, where I pass in the base path and select one of the images that we have already pre-uploaded. In this case, I will try to predict this image, Spider-Man 3006.jpg, which I'll add in over here. The predict function of the Detecto model returns three values, one being the labels, boxes, and scores. So let's go ahead and predict for this particular image. So the prediction is done. Let's print out the labels, boxes, and the scores. As you can see, the labels were Spider-Man 3, Spider-Man 1, and Iron Man. And here are the bounding boxes for Spider-Man 3, for Spider-Man 1, and Iron Man. And the model has given us a few values that it has predicted. It has predicted with a probability of 0.533, that is 53% for Spider-Man 3, and 49% for Spider-Man 1, and 45% for Iron Man. So as we know, as we have seen the image, the Spider-Man 3006 is of Spider-Man 3. So the model is right and we've got a prediction. We can also go ahead and visualize these results. For that, we need to import a function from detecto.visualize. It's called show labeled image. So when we call this function, what we have to do is pass in the image, the boxes, and the labels. So as you can see, our model has predicted where the Lego figure would be. As you can see, the labeled image over here has all three predictions that we've got, but the first prediction is what we need. And if you observe over here, the scores are in the descending order format. So the first prediction is supposed to be the right prediction. So all we need to do is add in a 0 over here and 1 over here. And this would give us a prediction of Spider-Man 3, as you can see over here. So let us try it out for another image, just the prediction part. So I will go ahead and find a random image from here. Let's say I want to predict this one. I'll copy it, come down, paste it in here, and take a look at the prediction. And Here we go. Our model has predicted that there is a Iron Man Lego figure right here with a label on top of it. So this is how you predict, you build a custom object detection model and use it to predict. Please do like, share and subscribe to help with the YouTube algorithm.